Building a machine Building a machine learning model to predict construction disciplines in oil and gas projects. This video is based on an article published by Ahmed PMP in LinkedIn. Problem statement. In this exercise, it has been utilized machine learning techniques to predict the piping spool's erection daily production and the features that impacting the piping erection productivity in industrial and oil and gas projects depending on historical data. The features which have been selected as listed below. 23 features. Country. The data has been collected for construction projects in oil and gas and petrochemical projects in 5 countries. Egypt, 14 projects. Saudi Arabia, 10 projects. Qatar, 3 projects. UAE, 4 projects. Oman, 4 projects. We will study the impact of these features on the piping erection production. Then we want to train and test our models with the data we have, and then obtain the best model that can predict our daily production. The below figure showing our process from feature selection till predicting the data passing by training the models, testing, and evaluation. Next, solution statement. We will follow the below process in our problem solution. Fetching the data. Clean preparation data. Data visualizing and analysis. Training model. Evaluating the model. Next, evaluation metrics. Our problem is regression problem that will lead us to use the following metrics. Root mean squared error. Root mean squared error RMSE is the square root of the mean of the square of all of the error. The use of RMSE is very common, and it is considered an excellent general-purpose error metric for numerical predictions. Next, data analysis. 1. Data exploration. The shape of our data is 15,868 rows, inputs, and 29 columns, features, with total 460,172 records. Our target will be the erection column. The below table showing some statistics about our data. The maximum piping erection per day is 32,945 d.I per day. The minimum piping erection per day is 466 d.I per day. The mean piping erection per day is 6,938 d.I per day. The 75% of the records have piping erection 9216 d.I per day. Down below, we have samples of data regarding erection production in Egypt in 2005, Qatar in 2005, Saudi Arabia in 2015, Oman in 2011, UAE in 2017. Where the below tables are showing the first 5 rows in our dataset. 2. Exploratory visualization. The following figures show erection records following by charts showing average numbers of the average number of pipe fitters per year for each country, the average number of cranes per year for each country, the average number of riggers per year for each country, the average number of grinders per year for each country, the average number of pipe welders, C.S. per year for each country, the average number of pipe welders argon per year for each country. Now talking about heat map features. Features impacting the erection production positively listed in descending order as below. Obviously, the skilled manpower, especially pipe fitters, and equipment like cranes, the location like Egypt, the absence of HSE restrictions, the low heat index, the absence of holidays, the availability of material, and drawings impacting the erection production rate positively. Features impacting the erection production negatively listed in ascending order as below. Benchmark model. Now, we will train our data into different models comparing our results with the benchmark model. We will use the linear regressor model as a benchmark in which to compare our model's performance to because it is fast and simple to implement. We will implement the RMSE root mean squared error as a metric to compare other models' results. Algorithms and techniques. As we are implementing a regression problem, our strategy to implement the models below and comparing their results using our evaluation metrics to our benchmark model. 1. Linear regressor. Linear regression is probably one of the most important and widely used regression techniques. It's among the simplest regression methods. One of its main advantages is the ease of interpreting results. When implementing linear regression of some dependent variable y on the set of independent variables equals x, whereas the number of predictors, you assume a linear relationship between y and y equals beta plus beta x plus midline horizontal ellipsis plus beta x plus epsilon. This equation is the regression equation. Beta, beta, beta are the regression coefficients and epsilon is the random error. 2. Elastic regressor is a linear regression with combined L1 and L2 priors as regularize. A asterisk L1 plus B asterisk L2 where alpha equals A plus B and L1 underscore ratio equals A/A plus B.
3. Keras regresor.
The basic architecture of the deep learning neural network, which we will be following, consists of 3 main components. 1. Input layer. This is where the training observations are fed. The number of predictor variables is also specified here through the neurons. 2. Hidden layers. These are the intermediate layers between the input and output layers. The deep neural network learns about the relationships involved in data in this component. 3. Output layer. This is the layer where the final output is extracted from what's happening in the previous 2 layers. In case of regression problems, the output layer will have 1 neuron. Now let's talk about model methodology. 1. Data preprocessing. We will normalize our numerical data for computing speed. The below is our numerical data which will be normalized. We will implement dummies, zeros and ones, for our categorical data. The below is our dummies list. Preparation of our data for models training and testing. We will shuffle our data, then it will be divided by 90% for trained data and 10% for test data. 2. Implementation. Firstly, after the preparation of our training and testing datasets, we will implement our benchmark model, linear regression model, and calculating the metrics that we have discussed before. 2.1 Linear regression model, benchmark model. 2.2 Elastic regressor.
2-3 Keras regresor.
As seen, by increasing the number of epochs, the loss is decreased till reach the optimum at 50 epochs. Features importance for Keras regressor. Clearly, the highest features importance are the skilled labors like pipe fitters, grinders, and welders. 4. Results. 1. Models evaluation. Firstly, we will combine all the models together and sort their results according to our metric, RMSE. Obviously, the Keras regressor is the best model with least RMSE 1330, and this RMSE is acceptable as we are working with the target in thousands. Secondly, we will test our model with new data and we will observe the output. The first selection it will be as below. We will select country Egypt, with the features as below. The second selection will change the country to Qatar, with HSE restriction, yes, and we will fix other features as below. The third selection will keep the same features as per second selection except that we will change the heat index to high. Obviously, the drop in production due to the heat index is high in the summer season. The fourth selection, we will keep the same features as per third selection except we will change the working at height to yes. Clearly, there is more drop in piping production in case we are working at heights. 2. Justification and conclusion. The skilled labors are the most important features according to most of the models, then the project location, HSE restriction, temperature/heat index, political issues, type of material, consecutively as shown in the features importance. Artificial intelligence and machine learning considered being the future success key for any company. The pioneers in the future are those who take into account the artificial intelligence and machine learning in their decisions and in developing management techniques. The historical data is the cornerstone to build a good model with good results. Companies has to collect data and records, everything to be collected. Daily reports, area of concerns, manpower reports, equipment reports, accidents, incidents, daily temperatures, etc. The research can be applied for different trades like shuttering, steel fixing, piping fabrication, equipment installation, concrete pouring, steel erection, etc. And then we can implement the standard